Here we are looking at Module 2. For the most part, you're going to find Module 2 to be a little easier than Module 1. So congratulations through making it through the toughest part of the test. So let's go get started on our first section in Module 2, which is going to deal with slopes and intercepts and rates of change. So in looking at our first section here, remember, slope is going to measure the steepness of a line. So what is the rate of change? How fast is something moving or increasing? So we're going to have slope is going to go here. And remember, slope can be both positive or negative. And there are a couple of ways you can find slope. If you've got a graph, you can find the vertical change, which is the rise, over the horizontal change, which is the run. And remember, if you're given a graph in the Keystone exam, find 2 points that you can read very well, okay? And it doesn't matter what points you pick as long as you pick 2 points that you can identify. And then you're going to count 1, 2, 3, 4. So we rose 4, and we're going to run 1, 2, 3, 4, 5, 6. So our slope here is going to be 4 over 6, which will reduce to 2 over 3. So if you go back and look again at our graph a little bit, you can see right there, some of you may have picked this earlier point. And with that, again, you can see your rise is 2 and your run is 3. So as long as you're picking points, you're going to get an equivalent slope from your graph. Just make sure you reduce your fractions as you go. All right, so our slope formula is, if you don't recall that, it is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Now, the main issue most students have when they are finding the slope and they use that slope formula is they may be given x1 and y1 here, and then they'll use they'll use the x1 minus x2 when in the numerator they did y2 minus y1. And so your signs are going to be wrong. So as you're thinking through that, just make sure that you're keeping your points consistent. Sometimes you will see the formula y1 minus y2 over x1 minus x2. It really doesn't matter as long as you're consistent. So in this case here, if I were going to find the change in my y, I'm going to take this x right, or this y, 7 minus a negative 5, okay? So I'm subtracting y1 or y2 minus y1 over here. And then I must take the x value from this point because I used the y value first from that point in order to subtract. And then I subtract there. So what I end up getting is I get 12 over negative 12, which will reduce to negative 1. So just make sure that you are checking your signs and being careful not to mix up your y1s and y2s and so forth. Moving on to the next slide here. So just a couple of things. We use this little happy face to remind us that we can have both positive and negative lines. And then we can also have positive and negative slopes. And we have a slope that can be horizontal or a slope that can be vertical. Remember, with our slopes, slopes that are horizontal are going to be a slope of 0. Okay, the slope of 0. And then vertical, straight up and down, is going to be undefined because we end up getting that's undefined there. We end up getting that 0 in the denominator, and we can't divide by 0. Remember, with our x-axis, on the x-axis is what we call the x-intercept. That's going to go here, x-intercept. And as always, the x-intercept, the y value, is going to be 0. So that's extremely important to remember. And then the y-intercept, the x value, is always 0. Okay, and again, those intercepts are just where they cross the x or y axis. So if you look at this example here, you've got a y-intercept of 3, you've got an x-intercept of 4. The slope is going down, so this is going to be a negative slope with an x-intercept of 4. So those are the quick questions when you're given a graph. Just ask yourself, what's my slope, positive or negative? Where's my x-intercept and where's my y-intercept? And that'll kind of start to eliminate some answers right away. Don't be afraid to eliminate answers as you are working through a problem. Remember, linear relationships or linear functions can be written in several forms. We've got slope-intercept form, which is y equals mx plus b. This is great because it does show you the slope and the y value of the y-intercept. Remember, it doesn't give you the whole point. It just gives you the y value there. And then standard form is ax plus by equals c. Standard form is great because with standard form, you can quickly plug in a 0 for x and find the y-intercept, quickly plug in a 0 for y to find the x-intercept. So it's great for graphing. It's a quick way to graph if you have an equation in standard form. But remember, you can't just look at standard form and say, hey, here's my rate of change or my slope, or here's my y-intercept without doing a little bit of work. And then you have the point slope form. And I often remind my students, this is really more of a formula than a form. And all you're going to do is plug in a slope and the y value and an x value that you're given from the one point. And that will help you write an equation. We don't like to leave equations in point slope form, but it is a possibility. Okay, and then as we're moving on to graphing, okay, so in this case, what's the equation of this line? If you look, so we've got our y-intercept here of 3, right, positive 3, and our slope is going up, it's positive. So I'm going to search for points that I can read pretty well. And I think that point right there is great. That's 0, 3. And then if I use the point, I'm going to use this point 2,7 here. I think it's pretty accurate, 2,7. So we can rise from 3 to 7, and then we run 2. So our slope, I'm sorry, we rose 4. We rose 4 and we ran 2 for a slope of 2. So we get the equation y equals 2x. And then again, our y-intercept was 3. And finally here, we are looking at lines of best fit. And remember, with a line of best fit, it's just going to show a trend, okay? So we use scatter plots to kind of help us. So scatter plots is going to go here. And the line of best fit is going to be the trend line that comes fairly close to each of the data points. And with these, again, they're going to give you an example of a scatter plot. They are not going to expect you to draw a line of best fit without a graphing calculator, but you should be able to recognize a better line or a better option here. So that's kind of where we are with lines of best fit. Without a graphing calculator, you wouldn't necessarily all get the same line of best fit. What one person draws and what another draws is going to be a little bit different, but we can always look at which one is better. So as we start to look through these, this line right here, it kind of tends to favor most of the upper points of our scatter plot here, whereas and D, if you look, it's kind of looking like it's looking at the minimum points here, the lower points. C just kind of cuts right through there, and that really doesn't show the trend as well. So by just the process of elimination and using a little common sense, we can see that B is obviously the best option for drawing a line of best fit. And these are the kinds of things they're going to ask. They're not going to give you two options that are so close that you wouldn't be able to tell them apart, or you'd be torn. So again, just go with your gut and which lines seem to fit more data than the other, and you'll be in great shape. Thanks for listening. This is section 2, module 2, section 1. We'll be on to section 2